So hi everyone, my name is Maria, and as Stephen has mentioned, I'm a DevOps engineer. I've been in this industry for 6 years now, and I'm passionate about this topic because I currently work with Kubernetes in production. We manage almost 64 microservices with a company I work with in Germany, and we provide online lottery experiences to countries in Europe and the United Kingdom. So I'm really glad to share my knowledge with you and also learn from you. So by show of hands, I would like to know a little bit about my audience. How many of you have used Kubernetes in production? Okay, nice. So for this session, I think we'll dive deeper into the basics, and then we also do some advanced stuff a bit later. So the agenda for today, we're going to discuss, first of all, what is containerization, why we need to containerize our applications, and what we had before the concept of containerization came up. And then we'll do some introduction to Kubernetes and also the best practices for containers. And in this, we'll need to know whether we need to actually use Kubernetes for our applications. Am I loud enough for the people at the back?
Yes, you are.
Okay. So, what is containerization? So, this title is a bit straightforward. It's to containerize, to make a container, to package your application along with its dependencies, libraries, and everything that is needed to run your application. You package them in some form of a container. We could use the analogy of a ship. You're trying to ship your products from one port to another. So this is the same thing. You package your application and everything that's needed to run your application so you can run it on different environments. Yeah. So it can be able to run on the dev, on the test, or on the production environment without any problem, and another developer can easily borrow your image to run it on their machines without a problem. So why do we containerize? So there is this common problem where you make your code and now it's time to deploy, but then when you try to deploy it to an environment, it's not working. And you end up with a statement like, but it was working on my machine. So that's the common reason as to why containerization came up, to prevent this problem, to make sure that if I'm running the application very well on my machine, I can easily deploy it elsewhere and it runs still as expected without any issues. So the second reason, that brings us to the second reason, that is portability, where containers can run on any system as long as that system supports the containerization technology that you've used. So currently we have some containerization technologies, so the commonest is Docker. But in 2018, there was an introduction of another containerization technology, that is Podman. And Podman aims to solve some issue with Docker, as we shall see later. And then there's also another containerization technology for the Mac OS, which is ObStack. I would leave that to you for research. But in this, we shall look at Docker, which is the commonest. Yeah. And then the third is to have predictable deployments. So with this, you're sure that even if I go to an environment that is running Windows, it will still run as expected because the baseline is Docker. Faster developer onboarding. One of the main challenges for developers joining new companies is to onboard, is to deploy their application the first time, running dependencies. Some of these are very outdated with new machines. So with the presence of Docker, it's easy. You just run the image and you're good to go. The other point is isolation. So previously you have your laptop, you're trying to run 2 Python applications on your laptop. One application is using a requirement that has a different version. The other application is using the same requirements that has a different version. So if you try to run them on the same laptop, there are some sorts of conflicts. So to avoid that, Docker does the isolation, but whatever you're running in that container belongs to that container. It will not interrupt any other application running on your system. So, any questions so far regarding containerization? Very good. So this brings us to the topic of Docker. Docker is the pioneer of containerization. So the people who started Docker in 2013 were trying to solve the problems we mentioned above to bring up some sort of isolation. And it's just a way to package your software so it can run on any hardware. It can run on a Windows laptop. It can run on a Linux laptop or Mac OS. So the first step that you always have to have with Docker is to install it. Docker is available on their official website. And if you go to that site, you will see a list of steps that you could follow based on your operating system. So for those on Mac, you could select one option, whether you're using an Apple Silicon, an M1, or an Intel chip. And for those on Linux, there are also instructions tailored for that. So does everyone have Docker on their machines? Because I would like to see some people follow through as we go on. If you don't, you could try to install Docker based on the operating system that's running on your laptop. Can we continue? Okay. So once you have Docker installed, the first step is to verify that it's running on your laptop. So how do you verify that Docker is running? So it's a simple command, Docker -- version. So Docker -- version will show you the current Docker version that you're running. Another way to verify that Docker is running on your laptop is to look for the Docker desktop. Yeah. So there's this icon here. When you click to go to dashboard, it will show you that Docker desktop. So the Docker desktop is a way to simplify Docker for people who would not want to use the command line. Yeah. So you can talk to the Docker engine in 2 ways. You can talk to the Docker engine via the Docker desktop, or you could talk to the Docker engine via the CLI, as we've seen with Docker -- version. So a little bit about the Docker desktop. The Docker desktop has containers, as you can see on your left. It has images. You can manage all this from the interface without using the command line. But sometimes it's important to know these commands as a DevOps person, because you should always live on the command line, on the terminal. It looks weird for a DevOps person to manage stuff via the graphical user interface. So that's the reason why we're going to go through some of these commands, but you can always manage them from here. I'll also show you how we can do that. Then it also has an integrated Docker Hub. Docker Hub is like a store, we shall look at that, where you can push all your images and share them with others, yeah? And then it has Docker Scout. Docker Scout is for security. We shall see how that works later. So any question regarding this so far? Yes, please.
How much space do we need?
How much space do you need to run? Okay. Specifically, I don't know, depending on your laptop, which OS do you have? So you can find that in the documentation, how much exactly that you need. Okay. Then, after looking at the Docker desktop, sorry, and we verify the installation, the next step is to know the Docker ecosystem, what you need. So in the picture on the right, we see that there's a developer doing their source code. And to Dockerize their application, the first thing they need to do is to have a Docker file. You cannot have a container, you cannot have a Dockerized application without the Docker file. So what's a Docker file? A Docker file is a blueprint that tells Docker how to run the application. So how does it look like? So this is how the Docker file looks like. Yeah. It has a series of instructions that you can tell the Docker engine that this is how I want my application to run. The first bit is the from keyword. The from keyword, you're instructing the Docker engine to use that specific image. For example, if you're running a JS application, you're expected to use a node image. If you're running a Python application, you're expected to use a Python image. How do you find these images? You find these images on Docker Hub. So Docker Hub, you go to hub.docker.com and you're able to see these images. So when you click on Explore or when you search Docker Hub, type in Node. Node, you're able to find the different images. It's always advisable to use officially supported images by Docker, because sometimes if you use an unsupported image, you may be exposed to vulnerabilities that may be exploited by a malicious person and they find their way into your applications. So how do you know that the image is officially supported? There's this flag. Yeah, there's that flag that shows this image is officially supported by Docker. So it's good practice to always use officially supported images. And this shows how many downloads have occurred for that image. This is 1 billion plus, and the stars of that image. So we have, if I take you back a little to the Docker file, it's from node 18 Alpine. This image is got from the public Docker Hub, the public Docker repository. That is the Docker Hub where we've been. And the 18-Alpine represents something. 18-Alpine is the tag for that image, which is more like its unique identifier. Yeah. So what does this mean? So when you go back to Docker Hub, you check for the node image, you check for the supported tags and the respective links. So the image we're running currently is, okay, the image we're running currently is 18-Alpine. So I think if I check, if you could check, it is listed in here, and the -Alpine represents the size. Each of these tags show the size of the image. For example, if you check here, there's 55 MBs. It's always advisable to use a small image, as small as possible, so your application is not bulky in the end. Yeah. So you could always, it's good practice to always look at the size of the image before you deploy it. Then you select any variant of that image. So the reason why we have Alpine, we have Slim, we have Bookworm is because of the differences of what's contained in this image. If I click on this image, it takes me to GitHub, and I'm able to see what they have installed for me by default. Yeah. So I don't need to install it again in my Docker file. Is this clear so far? Okay. So that's where we get the best image from. If you're running a Python application, there are Python-based images. So you just check for Python. You will find many Python images with different tags. If you're running a JS application, Node images. If you're running Java, they're also there. Yeah? Yes, please. Yes. So you can have your image posted somewhere else. We have many registries. So every every cloud environment has its own registry. So sometimes you don't want to use the public image. Sometimes you have your own image, and your own image is hosted somewhere. For example, if you're in AWS, they have a registry, the ECR. GCP has a registry. I think that's the GCR. Azure has a registry. That is the Azure something, I'm not sure, but they have a registry. And to access that image from that registry, first of all, you have to do some form of authentication in your application. So your application knows where to find the image. For example, from Node version Alpine. So this is getting it from the public. So this is still getting it from our public. So it's getting Node 22.18 Alpine. Yeah. But now if you have your own registry, for example, I created a registry in AWS in ECR, and my repository name, for example, is the Kampala DevOps Community. So I have to reference it here, KDC / then the image path. But before this image is accessed, you have to log into your ECR. You have to log into your registry. So the reason why I'm also able to pull images from Docker Hub is because I logged in. I had missed that step. So to log in, you simply run Docker login. So Docker login will open up the browser. If it doesn't do that, you can click on that link. It gives you a one-time code. This one, paste it in. Then it authenticates you. Without authentication locally, your image cannot be fetched from Docker Hub. So is that clear so far? But you can always use other repositories. So the next bit, you're telling the Docker engine that I want to use the app folder. Like when you create a directory for me called app, that is my workspace. That is where the app is going to live inside the container. So this instruction just creates a directory. Then the next step is to copy the requirements files. That is the package lock.json and the package.json. They are copied into our current working directory, the /app. And the next thing would be to install dependencies. After copying the requirements file here, it's now available. We install all the dependencies, the libraries that your application needs. Then the next step is to copy all the files that are in your editor into the container. Yeah, so copy ... Then the next step is to run the build. We're going to do that. And after running the build, this is like compiling your code, yeah, to create a single folder that is going to run on production. Then the next step is to expose port 3000. The reason why it's 3000 in this case is because when I run my application, it starts on port 3000. That's the port I'm exposing here. Then the last step is cmd npm start to start my application. So I added a repository in my GitHub for those who would like to fetch and work around this. Okay, you can find this repository in my GitHub. It has some of these files already pre-made that we're going to run. So the first one is going to be Docker my app. We're going to try to Dockerize a simple Next application that just shows a simple text on the screen. So this is the file that we've been looking at here. Yeah. The first thing you have to do to Dockerize your application is to put the Docker file at the root of your application. So from node 18 Alpine, set the working directory, copy package lock.json, these two files here, copy them into the container, run npm install, copy all files into the container, run the build, expose port 3000. Let's get rid of these. Can you all see my screen? Yes.
The last one, which is start.
Yeah.
So where is that? We only 20 and the other one.
Okay. Well, that one is run because run only works when building an image. Yeah. The only thing that can bootstrap the container outside the build is CMD. So these are two different commands. The other only works when you're bootstrapping, and this one no, the other one works when you're building, but this run will not work with CMD. Yeah. So I would go into the Docker directory. This is where the Docker file is, but before I run the Docker file, I could try to run this application locally to see how it behaves, then how it will look like when we Dockerize. So npm, I think the command to run this application is npm dev, because I haven't built it, npm run dev. And it will just show Kampala DevOps Community. Yeah. So let's try to Dockerize this application. So the first step after having the file, is to run docker build. Wait a minute. So we are on this step now. We are trying to make an image. So you run docker build -t. Then the image name, we could call it KDC app. Then you add the context. The context is like the path of where your Docker file is. Yeah. So since it's at the root, we use dot. So it starts building. So as you can see the build process, step 1 out of 6 is running. That is, it's fetching the image from docker.io. That is Docker Hub. Then step 2, it's setting the directory. Step 3, it's copying the package.json. Step 4, it's installing dependencies, copying all files, then it runs the build for production. Yeah. So if we go back to this slide, I try to explain that command in detail. Docker build -t. -t tells the Docker engine that I want you to add a tag or to version my image. You remember in the Docker file what we mentioned, these bits, the 18-alpine, that's the tag. It's a unique identifier for your image. But if you don't specify the tag, what does it do? It defaults to latest. So let's see what it did. To see the images that have been created, I type Docker images, KDC app, and then the tag is latest because I didn't provide a tag, so it defaulted to latest. For production, it's good practice to always use tags in this format, semantic versioning. Yeah, it's always good to use tags in this format and not use latest. Latest is for testing and stage, but not for production. So semantic versioning shows the major, the minor, and the patch versions of your application. Then the image name can be anything as long as it identifies your application. Then the tag, if I had specified the tag here, that's what we would have, but I left it out. That's why it defaulted to latest. Then the path to Docker file, it's usually dot if you're in that specific directory. If you're not, you have to specify the correct path. So this explains more about the tag. It helps you to manage different versions. You need a tag because it's good to have different versions of your application. Sometimes you want to deploy another version of your application and not the previous one. So the tag is the only unique identifier because the image name will always be the same, but the tag is the unique identifier to differentiate between different versions that you want to run. And we also mentioned that you use latest for quick testing, yeah, but always use a specific version for production. So now that we have our image, the next topic would be the Docker registry. Once you have your image in place, the next step, you would want to share your image with other people in the team. You want to deploy it on another platform. How will it be accessed? It has to be accessed from a central location somewhere. So you have the option to use Docker Hub. Docker Hub supports private and public repositories. So public, it's available to everyone in the world, which is not safe. Private, it's available to you. As long as you authenticate as you can be able to fetch it. Then AWS has ECR. They all do the same thing, but also ECR supports public and private repositories. Then GCR, and then the Azure Container Registry, but they also behave the same. So if you want to push your image to the registry, the first thing you have to do is to tag the image to match the remote repository. What we mentioned when we are running the form, that you include something like a repository here. So you have to tag it to match the remote repository. So how do we tag the image? You run docker tag, your repository name, / the image name. So let's tag our image. So we have our image KDC app. I'm going to push this image to my Docker Hub. So I'll do docker tag KDC app. Then I give it my repository name, KDC app. So it's been tagged, and if I do Docker images, it's here. It's been tagged. We shall also look at how to reduce the sizes of these images because this one is large. It's advisable to have a smaller image so you can deploy better. And one way of reducing the size of the image is to add a .docker ignore, and a .docker ignore ignores unnecessary files. For example, node modules. Yeah. Then another way of reducing the size of this image is to use smaller images. Like for example, from node 18 Alpine, we saw that there are smaller images like Slim. So there are smaller images like the Bullseye Slim and Slim. So it depends on the size of the image. Then another way to reduce the size is to use Docker layer caching. If we have time, we shall also look at that. Okay. Now that we've tagged our image, the next step is to try to push it to the registry. How do we do that? You run docker push, then the name of the image. So docker push, but remember you have to be authenticated via Docker login on your CLI. Docker push, then you copy the image and you push it. So when you push the image and you check Docker Hub, it should show up. Yes. No, you don't need to trim it if it's already built. That's true.
You already have that Docker for you.
It was huge because I used the Alpine. Alpine is kind of small, but I think I should have used a smaller image. Yeah. But you need to find a way of optimizing this size. There's another method called multi-stage. I'll later show you another command that can create an optimized file that has the multi-stage builds, and we shall see how it works. So it takes some time. I think it depends on your network connection. But after it's done, you will see it in Docker Hub. Then after the image exists in the registry, the next step is you can always pull the image to check that it's working as expected. So as we are still pushing that image, I want us to introduce the container because it's the next step. The next step after the image is to have the container. So the container is run by the Docker engine. The way Docker is structured, it has a client-server architecture. The Docker engine is the server. It's what does everything we send to it. For example, if we send these commands, docker ps -a, it's the one that's implementing all that. Yeah. So it's the one that will create the Docker container for you. And that's also another point as to why Podman was introduced. We shall see why Podman was introduced, because to remove that client server dependency. This Docker container is stateless. When a Docker container is removed, all the data in that container will be lost. Yeah, it will be lost. So let's check if our image is done. Okay, it's still running. Okay, as it's still running, we can try to create a Docker container locally. Or before that, we can go to the Docker desktop to show you how the image already exists here. This is the image. It can still be managed on the Docker desktop. You can just click this, run, to run the image without having to use the CLI. You can delete the image without using the CLI. So if we try to run this via the Docker desktop, I provide the port 3000. I click on run. It will log the same as if it's on localhost. Then when I click on it, it will return the Kampala DevOps Community. Yeah. So if I check the CLI for running containers, I could just do Docker PS. Docker PS will show that we have a container that's running called, no, with this random name, because I didn't provide a name, so it's created a random name, and it's using the image KDC app latest. How do I stop this container? I can use Docker desktop to stop it, or I can use the CLI. So I can do Docker stop, then the container ID And if I do Docker PS again, it should be gone. Yeah. But if I do Docker PS-A, it will return all containers regardless of whether they've exited or not. If I want to run this container again via the CLI, I would do Docker. First of all, I'll do Docker images to check the KDC app latest. Then I'll do the Docker run -p. The P is the port, the container port on which we are going to access this application. So the first one, we are trying to do a mapping. So the first one is what you're going to put in your browser, localhost 3000. Then this one is the port that has been exposed in the Docker file on line 13. So Docker run -p. So this time I'll give the container a name. So I will call it KDC app. Then you also add its image, KDC app. So it will do the same like you saw in Docker desktop. If you go there, that's the same. If I Ctrl+C, it should not work. Yeah. But what if I want to, and then if I do a Docker PS, it should not exist because the container is ephemeral and it's gone because I've stopped it with a Ctrl+C. But what if I want to run this in the background without having to do the Ctrl+C? I will run my command again, but this time I will provide a flag -d, meaning run this in the background so someone cannot just stop the container. Wait a minute. Oh, container name already in use. So if I can get rid of that container name, or I can create a second container, KDC app 1. So you see, it's now running in the background. It produces this random string. Wait. It produces this random string to show that it's now running in the background. And it shows up here. So if I do a Docker PS, I now have this container that is called KDC app 1. Docker PS-A will show all containers that we have, KDC app 1, KDC app. But now, if I'm done using these containers, for example, the exited one, how do I get rid of it? I get rid of it by getting its ID and doing a Docker rm. So it removes that container. So the reason for this is it's good practice to always clean up your images and containers because they take up a lot of space, yeah, on your machine. For example, if we do Docker images, all these images are taking up all this space. So sometimes if you're not using the image, you just need to get rid of it. If it's not running any container, you just need to get rid of it. Sometimes you want to clean up the entire system for Docker. This is a dangerous command, but it's called Docker system prune. It will clean up all stopped containers, all networks that are not used by at least one container. It will clean up all dangling images, unused build cache, but we won't do that. Then let's check if our image is done pushing. Well, still taking a while, I think. Okay, but then that's how we run our containers, and you can always monitor them in Docker Hub here. Any questions so far regarding that? Do we have a question? Okay. So these are some of the commands. Docker PS lists all the running containers that we have. Docker PS-A lists the exited containers. How do we get into a container and see what's in a container? So we exec into a container. So for example, we can do Docker exec IT. We want an interactive terminal, so we can run some commands in that container. Then the container ID. Then the shell that we need. So sometimes it uses the shell, the SS shell, the postfix. So here you get into your application. If I do an ls, I'm able to see my application, how it has been packaged. Everything has been copied over, including the Docker file, the package.json. When it ran the build, it created its own node modules, even if we had ignored them the other side. Then also the app folder. So cd app, and we list what's there. It's this, yeah? So that's how the container looks like. It packages your application and you are able to see anything in that. So I can exit. Yes, please. Let's see. Yes, it's advisable to do that. So she's asking if she has in the same folder, she has a Python application and the other was a JavaScript application. Is it advisable to have different containers? Yes, for separation of concerns. Sometimes you need to have a container for the front end and a container for the back end. And that's why we shall look at Kubernetes, Docker Compose, tools that will help these containers talk and work together. So it's always good to have a separation of concerns. So are we on the same page so far? Any question? Yes. Container and image. Image is just a template. The image is the blueprint that you move everywhere. So for me as a developer, I'll give you the image and your job is just to run it on your machine. So the image is what we move everywhere, and in different environments, it's run. So it's the movable bit of this whole thing. So the container is the running process, yeah? The image is just the template that contains everything. It's like a blueprint. I can have as many containers as possible out of a single image. Yeah. Contains the dependencies, the libraries, everything. Yeah. Yeah. Yeah, you just push your image to Docker Hub, to ECR, you just push it there, like we've done. You push it, then someone from that location will just pull it and run the container on their machine. Yeah? Yes, please. If you delete the image, as long as you pushed it. So we can delete it and pull what we pushed. It will still be the same. Yeah. So our image was pushed to Docker Hub. And if we check where is it? If we check Docker Hub, you come to My Hub. We have, this is the image that we've just pushed. Yeah. HDC app. And it's available publicly. So this part of Scout being inactive, Scout is a new feature that was introduced recently. You can run Scout to check for any vulnerabilities, any issues in your image. How? You can run the CLI with Docker Scout image, or you can come to your Docker desktop, click on Analyze Image. You select the image, then you analyze it. Then Scout will be able to check for any issues in that image, report them to you, outdated stuff that you need to update, and then you ensure security for your application. So another thing, you can access Docker Hub from here. You don't always need to go to the website. So this is the image that we pushed. You can view in Docker Hub. You can pull the image. We could try to pull the image. You could do it from here or via the command line. So Docker images, if I do a Docker pull, we need its ID. We need the latest. And you also see in the image, there are commands that you provided in your Docker file. Change the working directory, run npm run, yeah? So they are bits compressed and compiled. So Docker pull, image name. So here it already exists, that's why I didn't bother. But if I delete this image, how do I delete the image? I do Docker. In case there is no container running on that image, let me try to stop this container. So I can remove the image by running Docker RMI. That. So now it's not available locally. Yeah. So now that it's not available locally, I can pull it from the registry where we pushed it by running a Docker pull. So it's been pulled, and if I do Docker images, it now exists again. Yeah. Now, if we want to run the container out of this image, we can still do Docker run -d to run in the background, -p 3000, 3000, image name, container name. We could call it test2. So it's running, and if we check localhost 3000, it exists. So yes.
Just curious, if you use a set command with a different name, it's complex with the quotes, but
yeah. Yeah, so now that there is already a service that's running with 3000, it will conflict. So if we create another container, test3, same ports, it will say that the port is already allocated. So I'll change that to 3001, yeah, or 3010. And it will, okay, there is another name, test3. So let's call it test 4 with 3010. And if I try to access localhost 3010, it should show the same thing. Is that clear to us? Yes, please. If what, sorry? Yeah.
So if I make changes to my project, do I have to create another image or do I?
Yes. So when you make changes to your project, you always have to build a new image. Yeah. You always have to build a new image because the previous image already has previous changes. Any other question regarding that? Yes, please.
There's no like some sort of like portrait of say you're working on a file.
Unless you use something like NodeMon that detects changes and then it restarts the server, you could do that.
So you can research somewhere to be updated.
Yeah, you could write a Docker file and you try to install NodeMon. Like you could add a step here. For example, npm install -g NodeMon. Then you start this server with the NodeMon command. You could also do that. That's an option. Yeah, another thing about the layers, it's not advisable to always have different layers. Like I have run, then I have run, then I have run. The more the layers, the heavier the image is going to be. So you have to make sure you use as less layers as possible. If you can combine the commands into a single line, into a single command with ampersands or something, you have to do that to reduce the size of the image. So is that clear so far? With containers, any other question?
So time you make the change, it's going to install the packages.
No. So Docker has some form of caching, like a build cache. So in case you make changes and you haven't made changes to dependencies, it will always use the previous cache. So you'll find that your build time will be smaller than when you first render the image. Yeah. So to start a container, to stop a container, Docker stop, Docker start. So another thing, we mentioned that containers are stateless. So if you, for example, you've kept your data in a container, the container is destroyed, that's it. You've lost your data in that container. So they try to introduce some form of persistence. And that's where volumes come in. Like you can use, for example, I can get a folder on my laptop and bind it to a folder in a container so that when I make changes in that folder, in the container, it is persisted on my laptop. In case that container is destroyed and I run another container and bind the same volume, that data will still be available. So that is the concept for volumes. So volumes are persistent data stores for containers, and the directory on the host machine, on your laptop, on the server, or wherever you're deploying, you can create a directory there and it's accessible by the container. For example, you're running a Postgres container and you're trying to store some data. Yeah. So the data inside the volume is not stored in the container file system, but it's stored on the host file system. So data in that volume persists even if the container is recreated. So we could try to rerun this image with a volume and try to persist data and see how that works. So So our image, KDC app. Okay, this one that we pulled from the registry. Docker run -v. I could give any directory name, demo volume. And I attach the demo volume to any folder in app. So I could say /app /data. I set the ports 3005, 3000. Then the image. So if we check this container, Docker PS, this is the container that has been created 10 seconds back. If we exec into the container, sorry, it's the shell, not bash. So if I list items in this container, we'll see that a data folder has been created, and the data folder is coming from this, yeah? The data folder has been created, and it mounts or it binds to the demo volume that's on my laptop. So if I try to store data in that data folder, I could say echo. I could write random text. Into data. Okay, this is a directory. My data. Oh, sorry, this is a file. So when we check this file, this text that we've written exists. Now, we want to destroy this container and create another container that mounts this volume. So I exit, and I want to destroy this container. Local stop, local remove, yeah? So let's create a new container with a different name. Docker run -v. Oh, let's use this command again. Docker run -v. Name test 5. So we've created a new container called test 5. And it's here. So if I exec into this container, I've not written anything in it, but it should have that data already since it's using the same volume. Oh, it's not a directory, it's a file. So you see already a folder exists in a new container, even if we've not written it there, because we used the previous container to write to that volume. The volume stayed on my laptop, and the volume has been mounted into a new container as it's running, and that data has persisted. So that is how they attempt to assist data with volumes. Any questions? Okay, you can also create a volume. You can create a volume on your own, but the commands for creating a volume, Docker volume create, then the volume name, Docker volume list to list the available volumes. Docker volume list, it shows you the available volumes. So on my local, we have a demo volume, and these were created elsewhere, but you can also delete the volume. I think it's Docker volume remove. Oh, the volume is in use by the container, so it can't be removed. So you have to first stop the container, delete the container, then remove the volume. You can also inspect the volume. Yes. Yes. Yes, there are cases where the volume is large and it hinders the performance, but that's where you get to know that, okay, my application is big. I have to use, for example, a commercial service for volumes. For example, EFS, Elastic File Shared Systems, then there's EBS, NFS, yeah? You have to look into all those options. Yeah, but this is just for simple tests. But if you have a production grade application, you have to look into commercial providers. Then you can also inspect the volume. Docker volume list. So you can inspect the volume. Docker volume inspect. Then the name of the volume. Then you see when it was created, which driver is running this volume. Is it the Docker driver or the local mount point where it's found, and then the name, the scope, it's on my local device. You can also prune volumes, and that's also another destructive action. For example, remember the Docker system prune? Even this one, you can prune and delete everything, but that's not advisable for production. Any questions? Because they'll chase you. They'll chase you because sometimes people don't have backup of that. And if you do a Docker system prune, you will remove all volumes that, even those that you're not supposed to remove.
Some local fields, setup.
So it depends because you've not specified the name of the volume to remove. It's destructive. So I'm not saying that it's local to your setup, but sometimes the server on which you deployed your application is a company-wide server. So if you prune the volumes there, you're just finished. You just go home. Yeah. So that brings us to Docker Compose. So she asked a question that what if I have a Python app, a JS app in a monorepo, and I want to containerize these? What happens after I have multiple containers? What next? Because I don't know what to do with all these containers. The next thing is there was an introduction of Docker Compose. So Docker Compose helps you deploy these containers simultaneously together. Yeah. So you just need a simple command. Yeah. If you have 5 containers that you want to run at the same time, yeah, so that you don't just go Docker run this, Docker run this. You can create a YAML file, and in this YAML file, you can define whatever you want to deploy. It will look for it. It will look for the Docker file, for that service. Then it will run it on your behalf. So previously, we had Docker-Compose, but as years have passed, this has changed. in that now, the moment you download the Docker, this Docker engine, like the Docker interface, the Docker desktop, that's the right word, it will also download Docker Compose for you. Previously, we used to install Docker Compose separately, but that changed. So now all you need is a Docker Compose.yaml, or right now with the changes, it's called compose.yaml just. And after having that file, the next step is you run Docker Compose app. This will run all these services together. You can Docker Compose stop. It will stop the services together. Docker Compose down, it will destroy all the services together. It works together, creates them simultaneously, destroys them together. But for massive scale, if you have so many microservices, you cannot survive with Docker Compose. You can use a tool like Kubernetes because it comes with extra features that Docker Compose does not have, as we shall see. Any questions so far? Good. Yes, please.
Yeah, is Docker Stats something that is still used?
Docker Stats.
Yeah.
I'm not sure, but we could run it.
Like, when you do the version of folders, like container environment.
Yeah. Yeah.
So then, I remember like Docker before Kubernetes this one. Okay, like when Docker finished, like Docker Stats.
Docker Swarm.
Oh, Docker Swarm, yeah.
Yeah.
Yeah, Docker Swarm. Like, is it something that is still used?
It's still used, but you know, with this field, if something is not so supported, people tend to use a platform that is more supported because there's more documentation. Docker Swarm is used, but on a smaller scale. But I think it also misses some functionality that Kubernetes can provide. And it's not always that you have to use Kubernetes, but if you just have a simple app, you could stick with Docker Compose or Docker Swarm. It's still in use, but the community is not as large as the field. Yeah. Then, how do you go about Docker Compose? Simple. You just need to have a compose.yaml. Just need to have a compose.yaml in your folder. And this is how it looks like. So, in this compose.yaml, you define the service name. So we no longer need to define the version because that was in the old Docker Compose. You no longer need to define the version, it's automatically picked up. So in this case, the root is the services. It's the services, and then under services is where you define that this is my front end. You could call it web, you could call it front end. And then the image, you could provide the image that we've already hosted. Or if you don't provide the image, you could, when you have your Docker file locally, you could just add the build. I think the build context right here, and then the path. I need to confirm how that's done. But that's the image. Then you define the ports. Then the volumes for persistence, we saw volumes. Then the depends on, makes sure that the service you've defined here runs fast. It's some form of priority. it makes sure that that service runs first before it runs. Then you attach a volume. Yeah. So in this case, it's mounting my local DB data volume to the Postgres installation. Yeah. So we could try and run this. So all you need is a compose.yaml in your application to run Docker Compose. So how do we run it? So if we go to this folder, so Docker Compose app is now pulling the image. Okay, what's the name of our image? It's called KDC app. Okay, port 3000 is already allocated. Let's call it 3080. So it has created Postgres first. That's DB1. This second service, because we said that it should depend on DB. This one should depend on DB. So DB1 is created first, then Web1 is created. Localhost 3000, we specified port 3080. So that's how Docker Compose behaves. But also, rather than running it actively on the terminal, you can run it in the background. Let's give this a different port, 3090. Oh, sorry, I didn't run in the background. 3000. So Docker Compose app -d to run this in the background. So the containers have started, but you're not seeing all this noise. Yeah. So they're running in the background, and when you do a Docker PS, they should show up 13 seconds back and a minute ago. You can also see these containers in your Docker desktop. So they are all listed here. The images are listed. The volumes are listed. Yeah. Any concerns with Docker Compose?
Maybe just about the YAML file.
Yes.
I was trying to understand the volumes for the web service.
Yes.
Do we need what does that mean?
So this one is actually trying to mount my current directory to the /code folder in KDC app. But this is wrong. It's supposed to be /app/code, because /app is my working directory. Yeah, good question. Then that's it. So after Docker Compose app, you can destroy them together by running Docker Compose down. You can stop them first if you want. Or you can run them, Docker Compose app. Then you can destroy them, Docker Compose down. So they've all been removed. Check your Docker desktop. Try to refresh. They should be gone. Yeah. So any question, any other question regarding Docker Compose? Does it make sense now that you have different containers, you want to manage them together, use Docker Compose? Now, as technology grows, there's a command called Docker init. This one will solve all your previous problems that I've been discussing. Docker init will create for you a Docker file. It will create a Docker Compose. It will create a .docker ignore. So Docker init detects the platform that you're using. If it's a JS application, Python, it detects and creates a Docker file for you that has been optimized. Yeah. So it speeds up a lot of work than writing manually what we've been creating. But we had to do that so you can get a grasp of the basics and the commands. So let's do Docker init and see how it works. So I'll get rid of the existing files. So let's run a Docker init and see what it does. So it asks, which platform are you using? For it, it detected Node because it's a Next.js app. Which package do you? And how do you start your server? How do you build? NPM run build. So I put yes. What directory is your build output to? So I think the compilation will go to which directory? Comma separate if possible. I could do dist, but I think it's reading from .next. Command to start the app, npm start. That's right. The port your server should listen on. 3000 is already in use, but that's it. So you see what has been created? It has created the Docker ignore for you, where it adds all these unused. Okay, files are not necessary when compiling your project. Then it added a compose.yaml for you. And this is how it works. So in the example I gave with compose, I was referencing an image already on Docker Hub. But sometimes you have not built this image yet. So what happens? There's build context. So you provide a link to the path where the Docker file exists. So it's build context. Then you provide the ports. So this is the Docker file for you. You can uncomment in case you have a DB service that you want to run. You can uncomment this. Then also the volumes are catered for. Yeah. Then it also creates a Docker file for you. Now, I want us to look at this Docker file. This Docker file follows the best practices. So you'll find that if we build this image using this Docker file, it will be way smaller than what we had. So what does arg do? Arg, arguments, like it's taking in arguments. It's a way of defining variables in your Docker file. Then from node, this variable that has been defined here is reused here. So we use a base image because this is a JS application. Then you set the working directory. Then this is what we call multi-stage builds. Yeah. So sometimes you don't want the content from this file to come into this file to make it larger. That's when you use multi-stage builds. And in multi-stage builds, you're like from node as base, then from base as depths, then from depths as build, like that. So the previous step, the previous image in the previous step is will somehow not contribute to the final result. So this is a multi-stage build. You have different from commands, and each from command references the result of the previous step, because the result of the previous step is usually toned down and smaller, and it doesn't bring everything that it needed to run, hence making your image a bit smaller. So this is a multi-stage build. So in this stage, you fetch the node image with everything you need, but maybe everything in that image you will not need for your final result. So that's why you're like from node alpine as base. After getting whatever you need out of that base image, you get its result. Then you create another base, that from base as depths. Then in that, after you've done whatever you need to do here, you get the result from that step. Then you make another stage from depths as build. Once that's done, you get the final image as final. Then you have a smaller image, because sometimes the stuff in these images are just for compiling. You don't need them for the final running of your application. So that's what Docker init does. Sometimes you just have to skip and run Docker init in your project, and that's it. You create a Docker file, Docker ignore, Docker compose for you, without having to create them manually. Any question regarding Docker init? So it speeds up a lot of tedious work than writing manually. So what are the best practices of Docker? So first of all, we saw that you need to use the official Docker images. Some people are just malicious. They will write code, push it into Docker Hub, and you fall victim. If you pull that image into your code base, you get other results. Yeah, you're open to attacks and vulnerabilities. So use official trusted images from verified repositories. Another thing is to use tags. We say tags are unique identifiers. They help you to version somehow your application. Then you limit layers. As we saw, don't have too many run commands, too many copy commands. Yeah, you limit all those layers. Secure images. You have to regularly scan these images for vulnerabilities. So Docker introduced Docker Scout, but there are also other projects that you can use to scan your images. There's Trivy scan. You can use Trivy scan to check for any problems. I think there's also Dependabot. There's Renovate. You can look into all those applications. Sorry. You have to clean up and remove unused containers and images to save disk space and improve manageability. You have to limit privileges. So another reason why Podman was introduced, Docker has a problem. Docker runs as sudo sometimes. It runs as the root user. Yeah. So sometimes you have to limit privileges. For example, if you're running your application as root, you can do something destructive in your laptop or in your server. So sometimes in your file, you have to define, there's a command, it's called user. That user command, you can add that to your Docker file. You set the permissions that you need this container to run as. Then that would be better. So Podman solves this problem that with Podman, it's rootless. You do not need to run as root. Then always keep your Docker images up to date and patch vulnerabilities. It will also show you that something is wrong with your images. So for example, I have images that ran over 6 years ago. It will directly show you that this image has not been up to date for some time. So this image is not safe to use. Yeah. So you should always keep your images up to date, patch any vulnerabilities to ensure security. Any question? Okay, so we have other container engines, and that's getting even more popular. We have Podman. Podman was created by Red Hat in 2018, and it solves the problems regarding security, running rootless. It solves the second problem was removing the client-server connection. With Podman, you don't need an engine. You don't need a central, for example, like Docker needs a Docker engine, which does everything for you. That's a single point of failure. Yeah. So Podman does not do that. Podman creates an instance of itself. It forks the process. It creates an instance of itself, and it does the rest for you. So transitioning from Docker to Podman is not difficult at all, because they're all based on the Open Container Initiative. The Open Container Initiative is a standard that dictates how containers should be pushed, how images should be pushed, pulled. So you'll find that the commands are the same. Yeah. Where you have Docker pull, they have Podman pull. Docker push, Podman push. Yeah. It's the same because they're all based on that same standard, the OCI initiative. Another thing that Podman introduces is the concept of pods. Yeah. So it's easier to work with Kube with Podman because it already has its defined pods. Unlike with Docker, where you have to create a pod for the container. Yeah, we shall see that. So the differences is Docker is not daemonless. A daemon is a background service. That's the engine that is running, that is doing everything for you. Podman is daemonless. Yeah, you just fork a process of Podman. You don't depend on any other background service. Rootless. Docker is not rootless. It runs as sudo. It runs as a root user. So you have to somehow manage permissions in Docker. Podman is rootless. Yeah, you don't need elevated permissions. Swarm support. Docker supports Docker Swarm. Podman does not. Docker supports Docker Compose. Podman supports Compose. There is Compose. All platforms, they run on all platforms, so that should not be a problem. So there's a commercial service for Mac OS, Obstack. You could also look into that, though it's not, it has a free plan, but later, if you are using production grade applications, you have to pay for it. Yes, please.
You should just compose the two. Still, it can be used in
Podman, yes. Yes. Mm. Mm. How popular is it? It's picking up. It's a new technology, and developers are just learning about it. I wouldn't say that its community is as big as the Docker community. Yeah, but there are other engines also. We have Containerd, and we have CRI-O. You could look into all that. Sometimes you may not want to use Docker. For example, in Kubernetes, some people use Containerd. and other engines. So it's not only Docker, but Docker is the most popular.
This question.
Yeah.
So with Podman, do you have like a specific Podman file or you use the same Docker file?
You have a Podman file. You have a different config file. I think we shall look at that when in another presentation, in case we have one. Yeah, but it's almost the same.
How is Podman like Windows containers?
How Podman performs on Windows.
Well,
Yeah.
Linux. Podman, we can find it in Linux. You heard of that.
Yes.
I'm wondering, like, if I'm going to run like Windows containers, like how is the support for Podman so far?
Yeah.
Windows containers compared to like, let's say Docker, because some environments they still use Windows containers.
Yeah, that's a very good question. That's a very good question for which I don't have an answer to. But you could find out. Yes.
So this.
Nice.
So when you define like, so like base images, for example, you try to bring the best. So you need like the base images for you to put that. Yeah, most then here say it's the security. Is there like a change in building time? Building time and problem. It's like more time in the difference.
Steve, shall we take a break? I think we take a break before we start queue. Like a 5 minutes break or something.
Yes, this is too much information, right? Yeah, from Docker to Docker Swarm, there we are. The ship is really sailing. So, as requested by our speaker, let's just have a 5 minutes break such that we can fast condense, right? Yeah, because the next ship, Kubernetes, now we are getting 1 container, 2 containers, 1,000, and probably we don't want the ship to, drown over in the sea, right? Yeah, so let's just take a 5-minute break, say hi to your neighbor, welcome them, because at the end of the day, we say we are here to connect, learn, engage, and celebrate, right? Yeah, say hi to your neighbor. You see, there was an interesting discussion there about Podman. I saw Podman recently, and okay, I thought probably one provider couldn't support it, right? Actually, like the tool I wanted to use had Podman, but all I just had to do was to change where this Podman to something like Docker, which I'm used to, right? Yeah, but it's all containers, right? Yeah, so at this point, say hi to your neighbor. Those who didn't get water, you can just put up your hand. I'll bring you some bottles. Let's just have a refill.